Last class we discussed some basic concepts like a what is a circuit, what is a network, and definitions like a node, loop, branch, and mesh. Today I'm going to explain different types of electrical elements. There are mainly two types of electrical elements. The first one it is called as a active element, second one it is called as a passive element. The first one is active element, active element, and second one it is called as a passive element, passive element. Active elements is this is nothing but a sources, and these are further it will be classified into three types. The first one it is called as a ideal sources, ideal sources, and the second one it is called as a practical sources, practical sources, and the third one it is called as a dependent or controlled sources, dependent, dependent, or we can call it as a controlled sources, controlled sources. What is meant by ideal sources? This in the ideal sources there will be a two types. One is ideal voltage sources and ideal current sources. These are the sources with zero internal resistance or zero internal impedance. Therefore, power loss will be no power loss, and it is called as a ideal sources. How to represent these ideal sources in the diagram? We can represent the ideal voltage source like this. These are the notation to represent the voltage source. This is the minus plus. Notation is you can represent it as E or V. And here this ideal voltage sources, there will be no internal resistance or no internal impedance. Therefore, you can write directly like this. And this is the representation of an ideal voltage source. So how to represent the ideal current source? This is the symbol for to represent the current source. Write a circle inside so the arrow mark like this is a symbol for the current source, and you can represent its notation as a I. So here also there is a no internal resistance or impedance parallel to the current source because it's the ideal source. So these sources are also called as a independent sources, and they contain only plot output characteristics. The characteristics for the ideal voltage source, like can write like this. The graph is drawn between the current and it is a voltage. When you vary the current, they will be getting the constant voltage source because there is a no drop because it's a no internal resistance or impedance in series with the voltage. Therefore, it will be no drop. Therefore, when you vary the current, the voltage will be constant. Similarly, for the current sources, if you draw the graph between the voltage and a current, then we will get a plot characteristics like this because the current will be constant even if you vary the voltage because there is no resistance or impedance in parallel with the current source because it's an ideal sources. Therefore, when you vary the voltage, current will be constant. Next is another one is practical sources. How to represent the practical sources? How to represent the practical voltage source and the practical current source? Sources which have the internal resistance or impedance, therefore it will be a internal power loss. So practical voltage source we can represent like this. This will be a representation of the voltage source where it represent a minus plus. And for the DC sources, DC circuits, you have to write a in series with the resistance like this. And this is the resistance and R. This is the representation of a E you can represent E or V, any notation. Some books they are represented as E, some book they'll be represented as a V. This is the notation. You can use any one notation. This is for the DC circuits. The representation of the for AC circuits means you have to write a circle like inside the write on a sine waveform, and again you have to write your impedance. You have to write a impedance in series with this voltage source and like this. And this is we can represent it as a V is equal to Vm sine omega t. This is the representation of AC circuits. This is for AC circuits and this is for the DC circuits. So what is the waveform we are getting for this? So we are getting the waveform like this. If you draw the plot, the graph between this current, this is the current and this is the voltage V for the ideal. So we are getting the graph for this already. I explained for the ideal because there is no drop, but here there will be a resistance in series with the voltage source. Automatically the voltage will be drop, it will be decreases like this. And this is for the practical graph, practical. Similarly, for the what is the practical current source? For the practical current source, we can represent a circuit like this. This is the current source. For the current source, you have to represent the resistance will be in parallel with the current source. That means you can represent like this. This is our resistance R and this the current is I. This is for the DC circuits. For the AC circuits, we can represent like this. This is the current source. Okay, and this is you have to write impedance in parallel with the current source, and this is I. This I is equal to, you can write it as Im sine omega t. So graph we can write like this. This is the graph for this, and this is the voltage, and this is the current. For ideal, we're getting a plot characteristics like this. Ideal, but this is practical. There will be when you vary this voltage, current will be decreases. Therefore, this is the practical the graph. Third one, it is called as a dependent or controlled sources. Third one, it is dependent or controlled sources. So dependent or we can call it as a controlled sources. Controlled sources. Dependent or controlled sources. These are the dependent sources. The source voltage or current, it is not fixed, but it is dependent on the some voltage or current in the circuit, or the voltage or current will be present in the some other location in the circuit. Therefore, it is called the dependent or controlled sources. That means the voltage or current will dependent on the some other element in the circuit. Therefore, it is called the dependent or controlled sources. So applications in electronic systems that uses either the transistor or vacuum tube, that's all we need a dependent, that is will be on controlled source. In this, there will be four types of the dependent or controlled sources. One, it is called the current controlled current source, voltage controlled current source, voltage controlled voltage source, and current controlled voltage source. The first one you can represent like this. This is a notation. Current controlled current source. Current controlled current source. So symbolically we can represent it as CC, okay, CS, current controlled current source. So this is the way of representing the dependent or controlled sources. This is the current source, you write a current source like this, and it's the symbol like this, and you can represent this as a K1 IX. This is the current source, write a current source controlled by current, therefore you have to write K1 IX. This is a current controlled current source. So another one is called as a voltage controlled current source. Voltage controlled current source. So you can represent like this: voltage controlled current source. How to represent it symbolically? You can represent like this: voltage controlled current source, like this. And it's a voltage, therefore you have to represent here voltage controlled current source now here. This is right, this is a current source. Write a current source here, and the notation is this is K2VY. This is the voltage controlled current source. So these are the current controlled current source, and this can be controlled some current flowing in the circuit. This is the voltage controlled current source. This voltage Vy will depend on some other element in the circuit. Oh, yeah. Next one more, it is called as a voltage controlled voltage source. Voltage controlled voltage source. Voltage controlled voltage source. You can represent like this: voltage controlled voltage source. Symbolically, this is a voltage source, therefore here you can write a voltage source like this. This is the voltage source. Represent a voltage source like this, and this is like this, and this is also like this. Okay, this is the voltage source, therefore you have to represent a voltage source and controlled by the voltage, therefore you have to write here K3VY. And one more, it is called as a current controlled voltage source. This is write a voltage source here, voltage source, so minus plus, and it is controlled by current, therefore you have to write here K4IX. K4IX. Current controlled voltage source. This is current controlled voltage source. Voltage source. Current controlled voltage source. So this is the voltage controlled voltage source. This is the voltage sources, and this can be controlled by the voltage that will be dependent on the some other element in the circuit. Current controlled voltage source. This is the voltage source, and this can be current controlled by using the current. This current will be dependent on some other element in the circuit. These are the four dependent or controlled sources. What are the four dependent control sources? Means one is current controlled current source, voltage controlled current source, voltage controlled voltage source, and one more, it is current controlled voltage source. Next, we will discuss what is meant by different types of classification of networks. Classification of networks. Classification of networks. Network can be classified as a linear and non-linear networks. Linear and non-linear networks. Linear and non-linear networks. A network is said to be linear if the principle of superposition is satisfied. So what is meant by principle of superposition? If you consider any network, consider any network, consider any network, okay, we are applying is an input that we can call as an excitation, that we can call as an excitations. When you apply the input, you will getting some response that we can denote it as a R1 of t. The excitation may be either it's a voltage or current. When you apply this voltage or current for the network, then you'll get a some output that we can call as a response. Here we are represented excitation as a E1t and response will be represented as a R1 of t. Again, you consider a same circuit. Again, you consider a same circuit, okay, and you are applying another excitation that you are denoted as a E2t. Then you'll get a some response that you can denote it as a R2t. Again, you can consider a same circuit here, same network, okay. Up then instead of applying individually, you can consider both the excitation simultaneously, that is E1t and then E2t. So you're getting the response will be sum of the uh, individual responses R1t, R2t. Those will be network satisfy this condition is called as a superposition theorem. Okay, and those networks will not satisfy this superposition theorem. That network you can call as a non-linear network. That network which satisfy the superposition theorem, then it is called as a linear network. Second one, it is called as a passive and active networks. Passive and active networks. Active networks. What is meant by passive and active networks? The circuit which contains like a only the passive elements like a resistor, inductor, capacitor, that is called as a passive network. The circuit which contains one active elements like either voltage, ideal voltage source or ideal current source, then network it is called as a active network. Next one, it is called as a unilateral and bilateral network. Bilateral networks. Bilateral networks. So what is meant by unilateral and what is meant by bilateral network? A circuit whose operation, that behavior, is dependent on the direction of the current through various elements is called as a unilateral network. For example, a circuit consists of a diode which allows the current flow in only one direction. In opposite directions, the diode will not conduct. Therefore, this will be called as a unilateral network. So, what is meant by bilateral network? A circuit whose characteristics will be behavioral, it will be same irrespective of the direction of the current through the various element. It is called as a bilateral network. For example, the circuit consisting of only the resistance. When a circuit contains a resistances, even if it is either directions, the behavior or characteristics will be same. But in the unilateral network, if you consider the diode circuit, in the forward bias, the diode will be conduct. In the reverse bias, the diode will not conduct. That circuit we can call as a unilateral network. So another one is called as a lumped and distributed network. Lumped and distributed network. Distributed networks. What is meant by lumped and distributed networks? A network in which all the network elements are physically separable, that network you can call as a lumped network. And elements which are not separated physically, that network we can call as a distributed network. For example, transmission lines having it contains a resistance, inductance, and capacitance through the entire length, and that cannot be separated. That is the we can call it as a distributed network. So I will stop at this stage. I will continue in the next session.